In this video, we are going to study in detail the E4 error code that may appear on carrier brand air conditioners. This type of code often causes concern among users, as it prevents the normal operation of the equipment. It is important to mention from the beginning that the meaning of the code may vary slightly depending on the model and series of the carrier air conditioner, so it does not always represent exactly the same fault in all units. Even so, in this video we will provide you with a complete and practical guide that will allow you to identify the most common causes of the E4 error in carrier systems and apply the necessary steps to resolve it in most cases, without having to immediately resort to technical service. As a first step, it is essential to determine what type of system your carrier unit has, whether it is a carrier inverter model or a conventional non-inverter model. This technological difference is crucial since inverter units operate with advanced electronic control of the compressor speed, while conventional ones work more simply through direct on and off cycles. For this reason, the meaning of the E4 code can differ between both types of equipment. Understanding this distinction will allow you to approach the inspection with more precision and avoid confusion during the diagnosis. In the case of carrier non-inverter or conventional units, we must mention that these generally have two temperature sensors located in the indoor unit, in addition to a temperature switch or compressor thermal protection. These components work together to maintain stable system operation and protect it from possible damage due to excessive temperature. If any of them fail, the system interprets an incorrect reading and activates the E4 error code as a protection mechanism. In this type of carrier unit, the E4 code is usually directly related to a malfunction in one of the two temperature sensors mentioned earlier. When one of these sensors stops working properly or sends an out-of-range reading, the electronic board detects an abnormal condition and, for safety, stops the operation of the system, displaying the error on the screen. Therefore, it is important to check both sensors before suspecting other components. The first sensor is responsible for measuring the temperature of the air that the fan draws in from the room. This information allows the system to know the average temperature of the indoor air and adjust the operation of the compressor and fan according to the thermal demand. The second sensor, on the other hand, is attached to the tubing of the indoor unit, and its function is to measure the temperature of the refrigerant circulating inside the pipes. This control is vital to prevent frost or ice from forming on the evaporator coil, which could severely affect system efficiency and obstruct airflow. Before performing any measurement or test on the sensors and before opening the unit, it is recommended to completely disconnect it from the power supply for several minutes. This is not only a safety measure, but it can also help to reset the electronic board, as in some cases, the E4 error may disappear after a full reset. If the error reappears when the system is turned on, the next step is to clean the air filter of the indoor unit. A dirty filter can alter temperature readings and cause the system to falsely interpret an overheating or out-of-range condition. Also, check that the airflow is normal and that the fans are working correctly. If everything seems to be in order, continue checking the electrical connections of the temperature sensors, since a loose contact or weak solder joint can generate the same error code. If the electrical connections are correct, and with the electronic board completely powered off, proceed to disconnect both temperature sensors from the indoor board. Use a digital multimeter set to the kilo-ohm scale and, with the sensor disconnected, place the meter probes on the sensor's connector. The reading should neither be zero nor infinite, as that would indicate that the sensor is short-circuited or completely open. If you have the technical manual of the unit, compare the readings obtained with the reference values indicated by the manufacturer. If you do not have the manual, you can perform a practical test. Rub the sensor with your hand for a few seconds. If the sensor is in good condition, the resistance value measured by the multimeter should gradually decrease as its temperature increases. This simple method will allow you to confirm whether the sensor responds correctly to temperature changes. If no anomaly is detected in the sensors, it is possible that the problem lies in the indoor electronic board, which could be misinterpreting the sensor signals. However, before assuming a board failure, another important possibility must be ruled out. In some models, the E4 code may be associated with the compressor temperature switch, which, unlike sensors, does not measure temperature gradually, but acts as a safety switch. This component stops the compressor operation when an excessive temperature is reached and opens the circuit, interrupting the confirmation signal to the board. In this case, it is necessary to check whether there is actually a compressor overheating issue or if the switch is malfunctioning. Carefully check the temperature switch connections to rule out loose contacts that could interrupt current flow. You can test the switch by completely turning off the system, disconnecting its wiring, and measuring electrical continuity with a multimeter. If the switch is closed, that is, in good condition, it should show electrical continuity. If it does not, it could be open due to an internal failure or activated by an excessive temperature. In the case of inverter units, the E4 error code can have multiple interpretations, as this type of technology incorporates more sensors and advanced electronic control systems. Depending on the specific model, there may be additional sensors located in the outdoor unit, which should also be checked using the same procedure described above. Some models may include the following sensors in the outdoor unit. A. Discharge or thin pipe temperature sensor of the compressor, which allows monitoring the heat of the refrigerant gas leaving the compressor. B. Refrigerant temperature sensor located at the condenser coil outlet, responsible for detecting the residual heat of the gas before it moves to the next system component. C. Outdoor air temperature sensor, installed on the external side of the coil, which allows the system to adjust performance according to environmental conditions. D. In carrier units, it is very likely that the correct resistance of a sensor located in the indoor unit at a temperature of 25 degrees Celsius or 77 Fahrenheit is 10 kiloohms. However, if possible, the equipment manual should be consulted. E. For temperature sensors located in the outdoor unit, it is also very likely that both the condenser coil or tubing sensor and the outdoor air sensor have a resistance of 10 kiloohms at 25 degrees Celsius or 77 Fahrenheit. However, for the temperature sensor located in the compressor's thin or discharge pipe, it is very likely that at 25 degrees Celsius, it will show higher electrical resistance values, in many cases around 55 kiloohms. In any case, if possible, the equipment manual should be consulted. If after checking all these sensors, the fault is still not found, the next step should be to focus on the high temperature switch, which serves a safety function similar to that of the compressor switch, in the high pressure circuit. If the error appears immediately after turning the equipment on, there is a possibility that this switch is permanently open, preventing the confirmation signal from returning properly to the outdoor electronic board, which immediately triggers the E4 error code. In this case, disconnect the unit from the power supply, separate the switch's wire harness, and measure, with the multimeter on the continuity scale, the two terminals of the component. It should show electrical continuity. If it does not, the switch is open due to an internal failure or activated by an excessive temperature.